This is a review lesson on simplifying radicals. So the first thing, vocab breakdown, what is a radical, what is a root? So that is just, it's the symbol right here. So that's a radical. Radicals, when they don't have a symbol out in front, like the one I just drew in this one right here, that there's really a 2 out in front. But radicals and roots can have other they're called indexes. You could have it a 3 out in front. You could have a 4, 5, 6. It's the opposite of raising it to a power. So if I look at, for example, 3 squared is 9. But the square root of 9, or you can say radical 9, is 3. So it's going backwards. It's asking you what number times the same number would give you 9, and that would be 3 times 3. So radical 9 is 3. So that's a short little blurb on radicals. Or you can also call them roots. So if I want to simplify radicals, the first thing, so we have radical 18. If 18 was a perfect square, awesome. We would just stay what the number was, but it's not. So anytime you are simplifying radicals, the first thing you want to do is you want to find the largest perfect square that divides the radicand. So the radicand is the number inside the radical. So in this case, our radicand is 18. So let's think for a second. I'm going to draw a thought bubble. What is the largest perfect square that divides 18? Well, think of perfect squares. Try 4. 18 divided by 4. That doesn't work. It doesn't divide in evenly. How about 9? Well, 18 divided by 9 is 2. So 9 is the largest perfect square that divides 18. So now we would rewrite it, step 2, as the product of the square root of the perfect square. So radical 9 times radical 2. And now we just simplify that. So radical 2, that's going to be an irrational number. So we want to just keep it as the irrational number, radical 2. But radical 9 is 3. So this would just simplify to 3 radical 2. And that's all you got to do. I'll do 2 more. I'll do 1 more with you guys. Actually, I'll do the next 2 with you guys. You guys can do the next 7 right now if you want to. But I'm gonna do the next 2 in case you guys are still have some questions on that. So, looking at 48, the highest perfect square that goes into 48. Just take your calculator. Do 48 divided by 4. Do 48 divided by 9. Do 48 divided by what would be the next perfect square? 16. So if you do 48 divided by 16, you're going to get 3. So 16 is the highest perfect square that goes into 48. So radical 16 is just 4. Radical 3 is an irrational number, so that just stays 4 radical 3. And that is completely simplified. And we'll do the same thing for 63. What's the highest perfect square that goes into 63? And just take your calculator and start dividing 63 by perfect squares. So you can list the perfect squares out here if you want to. There's 4, 9, 16, 25, 6 times 6, 36, 64. So I start with 4 so I don't skip anything. 63 divided by 4 doesn't divide evenly, but 63 divided by 9 is 7. So we 5 rad 9 rad 7. And rad 5 is 3, so it'll be 5 times 3 rad 7, which would be 15 radical 7. Because you would multiply because you would multiply 5 times 3 to get 15. I want you guys to do the next 5, and I'll show you the answers to those next 5 when you're done. So pause the video if you haven't. So here are the answers. I want to look at And we're going to look at a couple of them. So let's start with radical 128. You might not have saw that 64 is the largest perfect square, which is fine. You really don't need to take out the largest perfect square in order to get the answer correct at the end. But it just makes it a lot easier. Say you thought it was, I don't know, say you thought it was 16. So you did 128 and you divide it by 16. We do that real quick. 128 divided by 16. And you're like, oh, awesome. It's radical 16 radical 8, which would then simplify to 4 radical 8. That's completely fine as long as you notice 8 can get simplified more. So then 8 would become 4 rad 2, which would be 4 times 2 radical 2, which would be 8 radical 2. So you just have to simplify the radical again in order to get the completely simplified answer. I put number 4 in there because a lot of people will be like, oh, you can't simplify radical 289. Always just plug in your calculator. So in your calculator, just do radical 289 first to check to see if it's a perfect square. In this case, it was. It was just 17. So that's why I put that one there. The fifth one, the one on the bottom left. So here, you want to simplify the radical first, which I did here and here. So that would simplify to 8 radical 5, the radical 320. And then this is an important step. In order to correctly simplify this is what I do so I don't make any mistakes, because I see this mistake all the time. Literally all the time I see this mistake. I see a lot of people cancel out the 4 and the 4 here and forget to cancel anything out of the 8. Or likewise, they cancel out the 4 and 8, make this a 1 and 2, and they forget to cancel anything out with the 4 in front. This 4 in the denominator it's 4 divided by 4 and minus 8 rad 5 divided by 4. So we have to divide every term in the numerator by the denominator. So that's why I separate it into two fractions. I have 4 over 4 minus 8 rad 5 over 4. And then you just simplify from there. So 4 over 4 is 1. And then 8 rad 5 divided by 4. You can cancel out the 8 divided by 4 is negative 2. Negative 8 divided by 4 is negative 2. So it'll be net minus 2 rad 5. That's very important to do so you can correctly simplify this consistently. And then I want to quickly look at 7. This is what I see from 7 a lot. I see this answer. I want to know what's wrong with this answer. If you look at it, so I was like, okay, I know I can take out a 4 out of 1352. So I took out rad 4, rad 38, and then I didn't continue to simplify that because I looked at rad 338 and I thought to myself, well, that doesn't simplify anymore. But it does continue to simplify. So this is why it's important to take out the largest perfect square first, because it's easy to make mistakes like this. But if you don't, it's not that big of a deal. You don't have to worry about it because you could always take 338 and take out a larger perfect square from there. But I want to show you guys how much easier it is just to find the largest perfect square instead. So we're erasing this answer, and I want everyone to get their calculator out to show you how to fully simplify 1,352, because this is a large number to find the largest perfect square that goes into it. So what I'm going to do is I'm going to take 1352 and I'm just going to divide it by every single perfect square from the first one. Well, 1's the first one, but we don't want to worry about that one because it's not going to simplify anything for us. Starting with 4 and working my way up. So I'm going to have 1352. I'm going to first off divide it by 4. Okay, that works. But let's keep on going. 1352 divide by 9. Didn't work. 1352 divide by 16. And I'm going to work all my way up, 1352 divided by 25. And I'm just going to keep going like this with my perfect squares until I get the highest perfect square. So I'm going to 1352 divided by 36. So I'm going to pause the video now, and I'm going to put all of it. I'm going to keep on going 49 and 64 to see what it's going to be. So I got to 13 times 13, which would be 13 times 13 is the perfect square of 169. So I could use this if you want to. This is actually not going to be the largest perfect square, but I think it might be a little bit easier to stop at 13 times 13. But you can keep going if you want to. You can do 1,352 divided by 14 times 14 if you want to. But I'm going to stop here. So this would be, I'm going to go off to the side, and I'm just going to simplify this. So this would be rad 169 times rad 8, which would be 13 rad 8. But hold on. That 13 rad 8 has a perfect square in it of 4. So I'm going to keep on simplifying this. 13 rad 4 rad 2, which would be 13 times 2 rad 2, which would be 26 rad 2. So the highest perfect square that goes into 1352 would be 26 times 26. Let's check that in the calculator. 676. So that would be 1352 divided by 676. So you could have worked your way up to the perfect squares all the way up to 676. I chose to stop at 169, which would be 13 times 13, just because I thought it was a little bit easier. So let's rewrite our question. So we have, or it would be 4 plus 26 rad 2 all over 2. And now I'm going to split this up into two fractions. So it'll be 4 divided by 2 plus 26 rad 2 divided by 2. And we would divide that and simplify it to 4 divided by 2 is 2. 26 divided by 2 is 13 rad 2. And that is our answer. That's the importance of really getting, you want to try and get the highest perfect square, but in this case, I think it was a little bit easier to get a high perfect square, but maybe not the highest. But yeah, let's go to the next page. What if we have variables inside of the radical? So looking at the first one, radical 80 m to the 10th. So the first thing you want to do, so I'm going to do number 1 with you guys. I'm going to do number 1 and number 2 with you guys, and I'm going to have you guys try the last 2. And so the first one, the first thing you want to do is you want to, step 1, you want to split up each term. So let me write that down. Step 1, split up each term under the radical. So what I mean by that is I'm going to simplify this to radical 80 times radical m to the 10th. So after we have we split up each term under a radical, now the last step, and this is going to involve more than one step, is going to be we're going to want to completely simplify each radical. So let's take a look at radical 80 first. Radical 80, I'm going to write it again just so we can reference it. Radical 80, what's the highest perfect square that goes into 80? It would be 16. So that would be radical 16, radical 5. But how about m to the 10th? So we have to ask ourselves, I'm going to do a little thought bubble over here. So what number times itself is going to give me m to the 10th? Well, I know my base has to be m. And our exponents also need to be the same because it needs to be the same exact value. So when we multiply with the same base, we add the exponents. So it would have to be m to the 5th times m to the 5th. That would give us m to the 10th. So m to the 10th really just simplifies to m to the 5th. So now we can continue simplifying that rad 16, rad 4. So that would be 4, rad 5, rad 5 times m to the 5th. And then we always just want to leave our radical at the end. So this would be 4, write the coefficient on the variable first, 4 m to the 5th rad 5. That's just like good notation to use to write it like that. So that is our simplified solution. Now let's take a look at the second one. The second one is a little bit different. So let's just continue doing the same method. So I'm going to split up each term. So that would be radical 54, radical n to the 7th. So I'm going to keep going with what we've been doing. Radical 54, the highest perfect square that goes into 54 evenly is 9. So that would be radical 9, radical 6. Now we got to think of that variable. So thought bubble. What times what is going to give you n to the 7th? Well, I could do, well, we know the base has to be n's. N to the 3rd times n to the 3rd. That would give me n to the 6th. How about n to the 4th times n to the 4th? That's not going to work. That's going to give me n to the 8th. I could do n to the 4th times n to the 3rd. That gives me n to the 7th. But these aren't the same values. So we can't do two of the same values to multiply to get to n to the 7th. So what you're going to want to do here is a good rule of thumb. We're going to split up n to the 7th into the smaller even number just below 7, which would be 6, times n to the 1st. So I'm going to make this n to the 6th times n. So I'm still, what I'm really doing is I'm breaking up n to the 7th, and I'm breaking up into the highest perfect square that goes into n to the 7th, which is n to the 6th. But a good rule of thumb is that if our exponent is odd, it's not a perfect square. We can't get a perfect square out of it. So you would just take 7 to minus 1, making an even exponent, so it would be n to the 6th times n, or n to the 1st. And you're going to see what that's going to allow us to do. So radical 9 is 3. Radical 6 stays radical 6. N to the 6th, radical n to the 6th, is going to be, well, how do I get n to the 6th? By multiplying the same value by itself. It'd be n to the 3rd times n to the 3rd. So that would be n to the 3rd. And then radical n, can't do anything there, stays radical n. Let's write everything outside of the radical out in front. So that would be 3 n to the 3rd. And then what's inside the radicals? You can just multiply them together under one radical times 6n. It's kind of like the reverse of step 1, splitting them up. You can also write them under that same radical. So I want you guys to try the next two, and we'll go over them when you're done. So here are the answers to the next two. Notice I did the first step here, simplified by splitting up each term under the radical. And then I took each term on the radical. I simplified radical 75 into radical 25, radical 3. And then radical x to the 3rd, you got to make it x to the 2nd in order. That's the highest perfect square that goes in x to the 3rd, which is just the subtract 1 from the 3 to get the exponent of 2, times x to the 1st. And then to simplify from there, radical 25 becomes 5. Radical x squared becomes x. and you bring those out in front, x times x is x squared. Don't forget the negative. And that's how we would simplify that. And very similar with the fourth one. You don't have to, the y to the fourth, that's just the radical y to the fourth is just y squared. You don't have to change that to like y to the third, y to the first, or y squared, y squared. For the x you do, and why do we have to do this for the x? It's because it's x to the seventh is to an odd power, so we have to make it x to the sixth times x. So that's it. Here's a bunch of practice with simplifying radicals.